Assalamualaikum and good day everyone. So today we are going to continue with the third topic, which is the application of definite integral. So previously we've learned already everything about integrations, and the last subtopic will be the definite integral. So now we are going to use the concept of definite integral. So for this one we have two subtopic. The first one, the area under a curve and between two curves. So what we want to focus is area. So the learning outcome of this lesson, students should be able to find area under a curve and between two curves. So the first one under a curve, the second one is between two curves. So we are going to focus on area. So area between the curve or line and the x-axis. So now we are going to focus on the first thing, which is between curve and line or x-axis, curve or line and the x-axis. Okay, so when we calculate the area under a curve, the important first step is to make a sketch of the curve. So we need to sketch. So an area lying above the x-axis. So we have area at the top of x-axis, it will have a positive value. An area lying below the x-axis, it will be negative. So can we have area of negative? No, area shouldn't be negative. Okay, that's why we have a formula of area. It's an application of definite integral, means that we have to find the integration of the function from that specific point. So here we have a point A to B. So we will find out what is the area under the curve or line, and it's come from point A to point B. So actually this is it looks like a trapezium, right? Right. But because we have a curve here, not a straight line, so we cannot use the formula of trapezium, but we can apply the concept of definite integral, because integration of a function is actually area of under the curve. But we must know what is the value of A and B. We should have the limits. How about the area lying below the x-axis? So if it's below the x-axis, so this is our x-axis, so the graph is under the x-axis, then the area will be negative. So to get a positive area, what we need to do is to, yes, put the absolute notation after you find the definite integral of the curve from A to B. So just put the definite integral, so the answer will be positive. This is for the area under the x-axis. Okay, so let's start with the example. Find the area between the curve fx equal to x square and the x-axis and the line x equal to 0 and x equal to 2. So first step, what you need to do is to sketch the graph. So we have the x and y axis. So how to sketch the graph fx equal to x square? So it's a quadratic. So basically we have to make sure, first step is to know what is the shape of the quadratic function. Here we have x squared, so positive. So it should be a small function. And then the minimum point here, because the b is equal to 0, so the x coordinate of the minimum point is 0, right? Because minimum point we can find out by using b equal to negative 2, sorry, the x coordinate of minimum or a minimum point here, h equal to negative 2b or negative b over 2a, sorry, negative b over 2a. But since we have 0 of b here, so the h will be 0. So the minimum point, the x coordinate for the minimum point is 0. So how about the y? The y coordinate, so substitute 0 into the function. 0 squared is 0. So our minimum point is at 0, 0. Okay, suppose our graph will be look like this lah. It's a quadratic, right? Small and minimum point at the origin. But now we want to find the area between the function and the x-axis and the line x equal to 0, which is the y-axis, and x equal to 2. So it will be on the right side of 0. So x equal to 2 will be around here. So we don't have to sketch this area. Okay, so what we need to do, just draw the line x equal to 2 here. So it's a vertical line. Okay, so the area should be bounded by all of this, which is the fx, which is this is our fx, and the x-axis, this is our x-axis, and the point x equal to 0 and x equal to 2, the line x equal to 2. So the area will be around here. Okay, so this is the area that we want to find. Okay, so to find the area, what we need to do, after we find out the area, we just have to integrate the function. So because it's respect to in between that function and x-axis, means that we have to find the area with respect to x. Okay, so it should be integrate respect to x lah. Okay, so let's see the area. The next step what we need to do is to sketch the graph. This is our graph. This is the area we need to find. So it should be the integration of fx respect to x, and then it's come from a to b. So what is our fx? Directly it's given as x squared, right? So it's starting from 0 to 2. So our a should be 0, our b should be 2. So it's come from 0 to 2. Okay, and then we just have to integrate. So how to integrate x squared? Yes, we get x cubed over 3 from 0 to 2. And then after that, we just have to substitute the limits. So we get 2 cubed over 3 minus 0 cubed over 3. So it's the same as 1 over 3 of 2 cubed minus 0 cubed. So 2 cubed is equal to 8. So 8 over 3 unit square. Why unit square? Because it's an area. Area is a 2D dimensional. So you have to put unit square. Not unit, but unit square. Okay, so let's continue. Example 2. Find the area between the curve fx equal to negative x squared plus 4x minus 8, the x-axis, and the line x equal to 1, x equal to 4. So we have all the information given. We need to integrate respect to x. But now, do you know how to sketch the graph? Okay, so the previous one, I asked you to find the minimum point because it's a small function, right? But now this fx is a negative coefficient of x squared. So it should be a set function. So a set function should have a maximum point. So how many ways to find a maximum point? So we either use the formula h equal to negative b over 2a, or another method that we can do is to use the application of differentiation, right? We can find the stationary point by using the derivative. Okay, so to sketch the graph, so we have to determine the maximum point. So for this one, I want to use the application of differentiation, where we find the first derivative of the function f prime x equal to negative 2x plus 4. And then to determine the maximum or minimum point, we equate the f prime x with 0. So after that, we can find what is the value of x, the x coordinate of the maximum point. So negative 2x plus 4 equal to 0. So 2x equal to 4. So 4 is x equal to 2. So the x coordinate of the maximum point is 2. You can also check whether it is true or not. So we can use second derivative, f double prime x is equal to negative 2. So negative 2 is always less than 0. So any point will be a maximum point. Okay, so it is true. Then find what is the y coordinate. So y is equal to, substitute the point 2 into the function itself. So negative 2 squared plus 4 of 2 minus 8. So we have negative 4. So the maximum point is 2, negative 4. So on the graph, so we have a maximum at 2, negative 4. So this is our maximum point. And then the graph is in the form of set function. So we draw the set graph. So we have the graph here. But now The curve is, the area that we want to find is when the x is equal to 1 and x equal to 4. So draw the x equal to 1 and x equal to 4 line. Okay, so this is the line. So it should be bounded by all of these four information. The fx, which is this is the fx, and then the x-axis, this is the x-axis, and then the x equal to 1 and x equal to 4. So the area should be here. Okay, now how to find the area bounded by all of this information? Yes, we apply the integration, but see where is the region lies. So the region actually lies below the x-axis. So if it's below the x-axis, we have to put absolute notation after you find out the answer. Okay? So the area A is equal to absolute of integration of fx respect to x from 1 to 4. So the value of limit should be a value of x lah, because this fx in term of x. The integration is in term of x. So integrate negative x square plus 4x minus 8 respect to x from 1 to 4 and find the absolute of the answer. So how to integrate of this function? We have negative x squared will be negative x cubed over 3, and then 4x will be 2x squared or 4x squared over 2, and then negative 8 will be negative 8x. And then we have to substitute the limits lah from 1 to 4. So substitute 4 first. So 4 cubed is equal to 64. So negative 64 over 3 plus 2 multiplied by 4 square. So 4 square is 16. Multiplied by 2 is 32. And negative 8 multiplied by 4 is negative 32. So this 32 here can be cancelled out. 64 divided by 4 is a fraction. So we just let it in the form of fraction. And then for when we substitute 1, so we get minus of negative of 1 cube over 3 is 1 cube over 3 plus 2 of 1 square is 2, and then minus 8 of 1 is 8. So we have here is 2 minus 8 is negative 6. Okay, so expand, we have a positive value lah for both. Adding up, negative 64 over 3 plus 1 over 3 is 65 over 3. And then plus with 6. So the final answer is equal to 15 unit square. Okay? Okay. So now, the next, the unit square, you can write down it as square, or you can put 2 at the top of unit. Okay, so let's continue. Area between the curve and the y-axis. So previously we learned when we find the area between the curve and the x-axis. Now it's the y-axis turn. So the area of the region trapped between the curve x is a function in terms of y and the y-axis to the right of the y-axis, and the line y equal to c and y equal to d is given by. So we just have to integrate the function g of y respect to y, because the function is in terms of y. And then the value is should be starting from one value of y to the another value of y. So that's why from c to d. So this is the formula respect to y. So let's say this is our graph. This is our graph. So this is a function of x in term function of g in term of y. So the value here, the limit here is starting from y equal to c and to y equal to d. Okay, so this is region bounded by the function g and the y-axis. It's not to the x-axis, it's to the y-axis. So this area is on the right side of y, to the right of the y-axis. And then similarly, the area of the region trapped between the curve x equal to g of y, function g of y, the x-axis, to the left of the y-axis, y-axis, and to the left of the y-axis, and between the lines y equal to c and y equal to d is given by. So the area now, we need to find the absolute value. Why? Because to the left of the function, we will have a negative answer. Okay? So the graph is on the left side of the y-axis, so the area will be on the left side also. So the left side we need to find by using the absolute notation. Okay, so this function, this area is bounded by the function g, and y-axis and y equal to c and y equal to d. Okay, it's bounded by all of this form. Okay, so let's see example 3. The graph shows the curve y equal to negative x cubed. Calculate the area between the curve y equal to negative x cubed and the axis of y and the lines. So it's given the function y in terms of x. But they ask you to calculate the area between the curve and the axis of y. So y-axis. So, and between the line y equal to 1 and y equal to 2. So everything is given in terms of y except for the function here. So this function is in terms of x. Okay, so let's see how do we solve this type of question. So we have the graph y equal to negative x cubed, which is a a cubic function. So when y equal to 1 and y equal to 2, it will be at the top of x-axis, right? So this is the y equal to 1 and y equal to 2. So the area bounded by the function, the graph here, y equal to negative x cubed and y-axis and y equal to 1 and y equal to 2 is this area. So how to find the area? So notice that this area, this region is on the left side of y-axis. So the formula that we need to use is the one with the absolute notation. So to find the area, absolute of g of y respect to y from c to d. And now we know the c and d is equal to 1 and 2. It's come from 1 to 2. But what is gy? What is our function? The function should be in terms of y. What we have is y in terms of x. So we need to rearrange this function. So what is function g in terms of y? So let x will be the subject. So we have y equal to negative x cubed. Then how to get x as the subject? First, we bring the negative to the left side. So negative y equal to x cubed. Now to let x only on the right side or on the left side. So how about this power of 3? So we can eliminate the power of 3 by power of 1 over 3. So if we power x cubed with power 1 over 3, then the left side also need to be powered by by 1 over 3. So we have negative y to the power of 1 over 3 or cube root of negative y. Okay, so we have the answer here. X is equal to negative y to the power of 1 over 3. Why negative is still there? Why? Because actually x cubed is equal to negative y. X equal to cube root of negative y. Because it's an odd number, then the negative will be still there. So negative of y to the power of 1 over 3. Okay, we can take out the negative because negative 1 to the power of 1 over 3 is still negative 1. Okay, so we have the function x in terms of y, then we substitute the function inside the formula. So this negative y to the power of 1 over 3, how to integrate? So this is y to the power of n. So it will be n plus 1 over n plus 1, right? Y to the power of n plus 1 over n plus 1, which is y to the power of 4 over 3 over 4 over 3. So we still have the negative. And then after that, after the integration part, we just have to substitute. We can take out the 3 over 4, negative 3 over 4. So substitute the 2 and 1 into y to the power of 4 over 3. So 2 to the power of 4 over 3 minus 1 to the power of 4 over 3. So 1 to the power of 4 over 3 is 1. What about 2? 2 to the power of 4 is equal to 16. Cube root of 16 is equal to, I don't know. You can use your calculator directly, or if you calculate it, you will get the answer 1.14. Actually, the answer will be negative 1.14. But because of the absolute notation, we will have a positive answer. Okay? So, for question B, it's from y equal to, it's the area between the y equal to negative x cubed, y-axis, and the y equal to 0 and negative 1. So, negative 1 is below than 0 here. So, the area bounded by all of these four information is here. Okay, so how to find the area? So notice that this region is on the right side of the y-axis. Means that we don't have to put the absolute notation. Okay, we just have to find the area of G, integrate the G of y respect to y from C to D. So G of y we find out already, which is negative y to the power of 1 over 3. So it's come from negative 1 to 0. It should be start from smaller value to bigger value. So everything is respect to y. So integrate y to the power of 1 over 3. So we get the same as question A, which is negative y to the power of 4 over 3 over 4 over 3. So it will be negative 3 over 4 of y to the power of 4 over 3. Substitute the value. If you substitute 0 minus, we substitute negative 1. So substitute 0, we get 0. Right? 0 minus negative 1 to the power of 4 over 3 is negative 1. So it will be positive. Sorry. Negative 1 to the power of 4 is positive. Right? So we have a positive value here, 1. So negative 1 multiplied by negative of 3 over 4, it will be positive 3 over 4 unit square. Or you can directly, after you put the value 0 and 1, negative 1, you can just use calculator. Use your calculator to avoid careless mistake. Okay? So this is the answer for question B. So area between two curves. So this is a new part of the area application of definite integral. So earlier we want to find the area under one curve only with the respective axis. But now if we have two curves, which is the first one is y equal to fx and the second one is y equal to gx. If y equal to fx and y equal to gx are two continuous functions with f of x is more than or equal to gx on interval a to b. So this fx will be above the gx. So it will be at the top of gx from a to b. Then the area of the region between graph of two curve on a to b is given by the definite integral a equal to integration of fx minus gx respect to x from a to b. So we subtract the function fx to the function gx. So the bigger function, which is the above function, we subtract the lower bound, the lower function. Okay, so because fx is at the top of gx, right? So we subtract gx from fx. So let's say example, find the area between the curve fx equal to x squared and fx equal to negative 2x plus 8. So first thing you need to sketch the graph lah. So for x squared will be positive smart. So we have minimum point at 0, 0. So this is really basic function, quadratic function. And then for fx equal to negative 2x plus 8, usually we will find out what is the intercept. Or you can just substitute any value, any 2 points, 2x coordinate to find the y coordinate, and then connect the 2 points. So for this one, I want to find the x-intercept. When x equal to 0, y equal to 8, and when y equal to 0, x equal to 8. So we have these 2 points, 0, 8, 0, 8, and 4, 0. So this is our linear function, a straight line. So we have this graph when x equal to 0, y equal to 8. When y equal to 0, x equal to 4. Okay? Now, what is the area between the curve? These two curves. So it should be bounded by these two curves or these two functions. So we have the graph here and the line here. So the area bounded between these two curves is actually this area. So the formula is to integrate the fx minus gx, which is negative 2x. So the graph at the top will be here. The graph at the top is negative 2x plus 8. So minus with the graph at the bottom, which is the x squared. Right? But do we know we need to integrate from which part to which part? Okay, so it should be starting from the left side of x-axis, the smaller one to the bigger one. So how to find this value a and b here? So how to find the value here? So this value is actually starting from the first intersection between the function x squared and negative 2x plus 8, right? So this is an intersection point here, here, is the intersection point. So how do we solve the intersection? How to find the intersection between 2 points, 2 lines, 2 functions? We use the, yes, we use the simultaneous. We use the simultaneous equation. So because fx is equal to x squared, also fx equal to negative 2x plus 8, we just compare the right side here. So x squared is equal to negative 2x plus 8. So this is a quadratic. It should be x squared plus 2x minus 8 equal to 0. So how to find the intersection point for quadratic? We need to solve it by using the factorization or using the formula, right? Here we can apply the formula, the factorization. So negative 8, the factor is 4 and 2, right? So 4 and 2, because we have negative here and then here is positive, so it should be negative 2 plus 4. Okay, so we have x plus 4 and x equal to negative 2 equal to 0. So the value of x is equal to negative 4 and x equal to 2. So which one is smaller? Negative 4 is smaller. So the value of A, which is smaller than B, should be negative 4. Okay, so B is equal to 2. So the area we want to find, we just have to integrate of fx, which is negative 2x plus 8, minus the gx, which is x squared, and then it's mass from negative 4 to 2. Okay, the intersection point between the two curves. So integrate to negative 2x plus 8 minus x squared. So we get negative 2x squared over 2. So negative x squared plus 8x minus x cubed over 3 from negative 4 to 2. Substitute the value. We will get substitute 2, we get negative 2 squared plus 8 of 2 minus 2 cubed over 3. And then substitute negative 4 minus with negative of negative 4 squared plus 8 of negative 4 minus negative 4 cubed over 3. So use your calculator, we will get the final answer equal to 36 unit square. Okay, so this is how we find out the area between two curves. So let's see the last example of this lecture. So find the area of the region bounded by between the fx equal to x cubed minus x cubed, yeah, minus x, and gx equal to 3x. So this is a cubic function. This is a linear. Okay, so how to, first of all, we need to sketch the cubic, right? So how to sketch a cubic function? Okay, first of all, we need to know what is the basic shape, right? So this is a cubic. So the basic shape will have two. It's either going up or going down to the right, right? And then we need to find what is the roots lah. Why? Because it will be passing through x-axis, right? So it will be passing through x-axis. So we can find out what is the roots. So first of all, this fx is equal to x cubed minus x. So we have a common factor here before we use calculator. We can see that we can factorize out x. So what's left inside bracket is x squared minus 1. Okay, if you use directly your calculator will give 3 answer of x. Okay, where when it's equal to 0, then we get x equal to 0, and then x squared minus 1 equal to 0, which is x equal to, or factorize out x squared minus 1, it will be x minus 1, x plus 1 equal to 0. So we have x equal to 1 and x equal to negative 1. Okay, so these three value, x equal to 0, x equal to 1, x equal to negative 1, is the x-intercept, okay, of the cubic. So our graph will look like this. So this is our x-axis, this is our y-axis. So the graph is a smile, because positive smile, sorry, it's going up. Okay, so because it's a positive, and we have intercept at 0, the origin, negative 1 and 1. So we can sketch our graph, and it should be intercept all these value. So the graph will look like this, right? So must pass through this, all of this point. So this is our graph. Okay, so this is a function of fx equal to x cubed minus 3. Okay, it's going up because it's a positive x cubed. And then we have a graph of 3x. So the graph of 3x, so because it's a linear, when x equal to 0, we will have y equal to 0. So we have intercept at 0. So how about the gradient? So because it's a 3, so it's going up to the right, right? So positive gradient, so the basic shape will be like this. So we just have to sketch the graph like that, huh? So this is our graph. Let's say we sketch like this, huh? Sorry. Why? Because it didn't pass through the x-axis. Okay, it should be passing through the origin. Oh, sorry, not the axis, but origin. Let's say this is the graph of fx equal to 3x. So we want to find the area bounded by between these two curves. The area bounded by these two curves will be this area, right? This area and this area. So we have two areas that we need to find the value, right? These two areas. So it should be separated into two parts lah. Let's say this is part A, this is part B, two different areas. But now what we need to do is to find the intersection, right? What is the value here? What is the value here? Here we know already it's 0, right? It's intersect at 0. So we just have to find this value A and B here. So how to find the intersection point? We just have to compare, equate these two equations. Okay. So we need to equate fx equal to x cubed minus x with gx equal to 3x. Okay, to find the intersection point. So just equate fx with gx. So we have x cubed minus x equal to 3x. So if we bring it together, so we have x cubed minus 4x equal to 0. Okay, right? We bring it to the left side. So we will have negative 3x here. Right? So because we subtract 3x on the right side, so the left side should be subtracted by 3x also. So negative x minus 3x will be negative 4x. Okay, after that what we need to do is to factorize out lah. We can find the roots here. So x, factorize out x, we have x squared minus 4 equal to 0. So x here directly equal to 0. Another one is x squared minus 4 is equal to 0. So to solve x squared minus 4 equal to 0 is the same as factorizing. So we get x minus 2 and x plus 2 equal to 0. So x is equal to 2 and x equal to negative 2. So to find the intersection, to find the area, so we have these two areas. And it's from, let me sketch it correctly. It's from negative 2 to 0. This is origin. This is negative 2 and then to 0. And then another one is from 0 to 2. This is A, area A. This is area B. So we separate into two functions lah. Two different areas. So this is our y, this is our x. So for this one, right, to find the area for A, we need to look at which function at the top. So this function is fx, this function is gx. Fx is x cubed minus x, gx is 3x. So for this area from negative to find the area, right, from negative to 0 for A, right, for A, the graph at the top is the graph, the curve, the cubic graph. So it should be x cubed minus x, subtract the linear graph, the 3x graph, minus 3x, respect to x. And then we should add up with, starting from for area B lah. Area B starting from 0 up to 2. Which function at the top? The function at the top is the function linear, which is gx, subtract with the bottom one, which is the x cubed minus x, respect to x. So this is for A, this is for B. We need to find it separately because the top function is changing. So how to integrate? So integrate the function here, x cubed minus x minus 3x. Simplify first, we get integration of negative 2 to 0 of x cubed minus 4x respect to x cubed. And then for this one, simplify, we get 3x minus negative plus, so 4x minus x cubed from 0 to 2 respect to x. Okay, now do the integration. We get x to the power of 4 over 4 minus 2x squared. So 4x squared over 2 is 2x squared. It is from negative 2 to 0 plus with 4x squared over 2 is 2x squared minus x to the power of 4 over 4 from 0 to 2. Now you just need to substitute the value lah. Okay. Substitute the value. It's what is the function? It's x to the power of 4, right? X to the power of 4 over 4 minus 2x squared from negative 2 to 0 plus with from 2x squared minus x to the power of 4 over 4 from 0 to 2. So we now substitute the value. 0 to the power of 4 over 4 minus 2 of 0 square minus with negative 2 to the power of 4 over 4 minus 2 of negative 2 square. Okay, and then add up with 2 multiplied by 2 squared minus 2 to the power of 4 over 4, subtract with, everything will be 0 lah. Here will be 0, everything here will be 0, right? So because we need to substitute into x, so everything will be 0. So what do we get here? Here 2 to the power of 4, 2 squared is 4, 4 squared, 4 to the power of 4 multiplied by 2 is 8, 8 to the power of 2 is 8 multiplied by 2 is 16. 16 over 4 is 4. Here is 2, 4. 4 multiplied by 2 is negative. This is negative 8. So 4 minus 8 is negative 4. Multiplied by negative will be 4. And then here also, this is 4, 2 is 8. 16 over 4 is 4. 4, 8 minus 4 is 4. So 4 plus 4. So the answer will be 8 unit square. Okay, so the first area will be 4, the other area will be 4. So the total area will be 8 lah. So we have to separate because the top function changing at 0. Okay, so this is how we solve for this type of question. Hopefully you guys understand and try to do the tutorial question. Okay, so thank you class.